All right, today's lesson is going to be on law of cosines. And the first couple things are going to be rather in depth and a little bit mathy, so feel free to pause it, stop it, back it up, whatever you need to kind of get it. But we're going to start by talking about how to find the measure of all the angles if we have three sides. Notice I cannot use the law of sines because the law of sines would require to know at least one of these angles, and then I could find any of the other ones, so I cannot do that. So what we're going to do is kind of a long process here that's going to require me to drop an altitude down here, because if I have an altitude, then I can find, using kind of regular trig, these angles over here, also using Pythagorean theorem now that I have a right triangle. So what I'm going to do is I'm going to call this distance from A to where the altitude is, I'm going to call that x. And since that's x, I'm going to call this side over here 13 minus x. So again, if I were to add these two pieces together, it would equal 13. Then what I can do, excuse me for that, is I can look at triangle number 1 right here, and I can use Pythagorean theorem and just say that x squared plus, oh, this is an h over here, I guess I should put that in there, plus h squared, that's our altitude or height, has to equal the hypotenuse squared, which is 12 squared, and I'm going to go ahead and square that out to 144. Now I could do the same thing over here in this triangle. I would have, I'm going to run a little bit out of room here, but that's all right, we can make it work. 13 minus x squared plus h squared equals the hypotenuse, which is 11 squared, which is 121. And I'm going to go ahead and expand this algebraically. If I go 13 minus x times 13 minus x, I would get 169 minus 26x plus x squared, and then I would continue with the plus h squared, and that still equals 121. So that's the blue side. This is my green side, and again, let's just work at a goal of trying to find what the measure of angle A is. So we're just going to go with the measure of angle A here. I'm going to erase that crazy line that just showed up for no reason at all, and get back on track, no problem. So if I want to find the measure of angle A, what I also know is that if I use this triangle over here, and there's a number over there, so I can use trig, and just looking at this little triangle, if I'm interested in A, again, I could do this from B if I wanted to, or C, I would have to drop a different altitude because C is kind of split. But if I want to do it from A, I now know that the cosine of A is equal to adjacent over hypotenuse. So that equals x over 12. And if I knew what x was, then I could calculate this. So we are going to use a little bit of substitution from this blue Pythagorean theorem into this green Pythagorean theorem. So on the blue one, I'm going to come over here and I'm going to get h squared by itself. So if I want to get h squared by itself, I'm going to subtract all of this stuff away. So that would leave me h squared equals, when I subtract this stuff away, I'm going to subtract 169. Let me do this in this lovely shade of purple. So I would have to subtract 169. So I come over here and I subtract 169, and that should give me a negative 48, I believe. And if I then add the 26x, having some technical difficulties writing today. No worries, plus 26x, and then I would have to subtract x squared, And so that would be minus x squared. And then all of this purple stuff I can put in place of this h squared because it's what h squared actually equals. So I'm going to come to the green and I'm going to come down here and I'm going to make that substitution. I'm going to plug all of this purple in for h squared. So that would be minus 48 plus 26x minus x squared. That is all what h squared is. That's all that is, and it has to equal 144. And now I just have a single variable, x. And you may have noticed very quickly that this x squared is subtracted and gone. So I'm going to solve for x. So I'm going to add 48 to the other side. Boom, plus 48. And I will have 26x equals, and if I add those up, I should get 192. And if I divide both sides by 26, I can figure out what x is in this particular situation, which is 7.3846. And now I know what x is, so I can come back to this equation right here, and I can say to myself, well, cosine of a has to equal 7.3846, etc., over 12. Now I can figure out a by doing an inverse cosine and type this right into my calculator, running out of a room here, and a, if I did it on my calculator, would be right about 52 degrees. And so there we go, boom, figured it out. Now, I'm not going to lie to you, that was very strenuous. So what we're going to do is instead we're going to look at how can we do this generally for any of these situations without having to do all of that work. So we're going to come up with, I'm going to show you how the law of cosines comes to be, and then you'll be able to use it. And again, to do so, I need to be able to drop an altitude. There it is, a height. And I could also, on an obtuse triangle, that would be outside of the triangle. And so we're going to call this, just like we did a minute ago, this we'll call x, this little bit right here, which means this side would have to be c minus x for you to get an entire side of c. So we've split this side over here into two pieces, x and c minus x, kind of like we did a second ago. And the same thing could be consistently done over here, where I can make that piece x, whatever length it takes to get your altitude over there to make a perpendicular. Now I'm just going to show you for the acute triangle, and similar process could be done for the obtuse triangle. So what we'll do is we'll start by looking at this particular triangle using Pythagorean theorem, like we did a second ago. So we would have c minus x squared plus h squared equals a squared. And I'm also going to do something similar with this triangle, like we did a second ago, which would be x squared plus h squared equals b squared. And because I'm interested in, as marked here, angle A, I'm going to write this up here, then we know that the cosine of angle A is the adjacent over the hypotenuse, so that would be x over b. So we're going to do something similar that we did a little bit ago with some substitutions. One Pythagorean will substitute in, so we're basically going to do h squared over into here, and then this time, since I'm not going to be able to get x because I have no numbers, I'm going to just have x in terms of the cosine and the side b. So what I'm going to do first, like I did a second ago in purple, I'm going to go, well, if x squared plus h squared equals b squared, then h squared is b squared minus x squared. And now this is what h squared is equal to, so here is h squared. So what I'm going to do is I'm going to substitute b squared minus x squared right here. And so I'm going to do two things. I'm going to expand the c minus x squared, and I'm going to substitute the purple. And then we will have our expression. So if I expand the c minus x squared, I should get c squared minus 2cx plus x squared. Now I'm going to do a substitution here. H squared is equal to b squared minus x squared, so plus b squared minus x squared. And that still is going to equal, I'll go back to green for now, equals a squared. Just so you can kind of see the purple substitution went in for h squared and I expanded. And once again, we have some good things happening because this x squared minus x squared is going to go. And again, so if I'm trying to find maybe, here's my angle I'm dealing with, here's the side across from it, so I'm just going to put this a squared over here on the left, equals, and I'm going to take the b squared and the c squared, I'm going to put them, they're being added, so I'm just going to go equals b squared plus c squared minus 2cx. And so now if I can get rid of this x, then this expression will all be written in terms of the sides of a, b, and c. So up here, I can get x by itself by multiplying both sides by b. So if I multiply both sides by b, boom, I have an expression for x. It's b cosine a. So now in place of this x, I can put that b cosine a. So this expression becomes a squared equals b squared plus c squared minus 2c times all of this. And again, it doesn't matter what order I multiply, so just for sake of putting things in alphabetical order, I'll put bc instead of cb. And this is the law of cosines right up here. We just did it. I do want to point out that, and we'll talk about this again in a minute, this angle A in the cosine expression is the side opposite that's over here by itself. So these other two sides, B and C, are the ones that include that angle A, kind of like we did with law of sines. So I know that was very strenuous and long, and now we know the law of cosines. So I'm going to write it down again up here just for fun. And again, these letters do not have to be A and B and C. It could be any letters. But what matters is the fact that this cosine, whatever the angle is over here, has to be across from the side that's over here. And these other two sides have to capture. So notice how A is in between the B and the C. This would be side C, that's side B. So this letter expression is perfect for this. So if I want to find what this equals, I'm going to go a squared equals, and in this case, B is right there. So 21 squared plus, that's side C, 15 squared minus 2 times 21 times 15 times the cosine of 105. And this is an expression you can type into your calculator. I do want to point out that that is what a squared equals. That is not my answer. That, if I type all of that in and hit enter, would equal 829.0559, etc. And we keep all of this in our calculator, and we don't round or deal with significant digits, sig figs, until the very end. So at the end of this, I would have to take a square root. And so the side length of A would be approximately equal to 28.8 centimeters. So again, this formula is on your formula sheet. You do not need to memorize it, but you do need to understand that this angle is in between these two sides, or that this angle that you're missing is way opposite the side you're trying to find. So you are going to pause the video right now. I'm going to erase this just so you can kind of see. And you are going to make an attempt at, here it is, you try, find the length of the remaining side. That side is supposed to be written over here. And again, this is the angle. It's in between the two sides. So again, just like